Welcome, and we're glad you could be with us today. We're going to go through some introductory background material in PowerPoint, and then I'm going to turn it over to Rodney to cover a final few slides and move into some demonstration. We appreciate your taking the time to be with us today. The target audience for this is really technical professionals and decision makers. We're going to, fill the hour with a kind of an introductory survey overview of what TBEST is and how it might be of use there, and it's the kind of presentation that we hope will give folks an orientation. You're not going to walk away knowing how to necessarily use the model, but you can certainly hopefully decide if this is a tool that you want to learn more about, and in the process today we'll hopefully give you a lot of directions as to how you might accomplish that if you want to continue to learn more about TBEST and how it might be of use to in your particular situation. A couple objectives here. We want to give an overview of critical characteristics of the modeling and the approach that it can bring to transit service planning. A little bit of a preview of some features and capabilities that have been integrated into the model, and a little bit of direction for future plans with the model. And then again, as I indicated, a demonstration. It is a powerful GIS tool, and the visualization through a demonstration is really critical to appreciating it. It is an effort that we've been involved in for a number of years now. This is the project team, myself and Dr. Chu have been instrumental in some of the logic and conceptual development. Mark Mistretta works with us on applications and administration. Rodney's been in the project through the duration as a software programmer and is the lead programmer on this and has been for some time, and probably most familiar obviously with the model. Martin Catalan, our GIS group, has helped us with a lot of the data and GIS capabilities and networks as well. And finally, this is an FDOT supported initiative. It's public domain, but it's something that FDOT over the past several years has invested in as a project or as a resource for the Florida community. But as you'll see as we talk, it's been used well beyond Florida as well. The current program manager for our model development efforts is Daniel Harris in central office in Tallahassee. What is TBEST? Transit Demand Modeling Software Package developed by FDOT, Public Transit Office. The state was looking for a comprehensive network modeling tool and as a software that could really help them address short and midterm transit planning. This isn't necessarily designed for long-range forecasting. It certainly can be used for that, but its real intention is to address and support short and midterm planning initiatives, particularly those that are required by FDOT in Florida. But as you'll see, it's useful for lots of other applications as well. And then we had a spectrum of objectives in terms of user-friendliness, cost-effective, scalable. We wanted a tool that you didn't have to spend 2 arms and a leg to get up and running in your environment, or be hardcore model calibrators to make it work in your agency. And we think we've been successful in building a tool that can be helpful to folks without necessarily extensive modeling backgrounds. DOT had some very specific kind of objectives and motivations for this. They wanted this friendly tool, but they wanted it specifically designed for transit. And there's a certain image of historically big models, regional models, were designed for roadways, and we tried to adapt them for transit. And they were looking for something that clearly was sensitive to transit service characteristics and transit agency needs. And the title comes from TBEST, comes from Transit Boarding Estimation and Simulation Tool, and we're currently, version 4 is out, and we're continuing to work and make improvements on it and adapt it to evolving softwares as time passes, with ongoing support from FDOT. We have use this to kind of articulate the benefits of having a tool. And it's important to realize the transit service changes are fairly dramatic, even in relatively short time frames. And these were just some examples of that, where we've had agencies where ridership has changed anywhere from plus 200 to minus 20% in less than a decade in various properties in Florida. We are being hit with changes in resource availability, unfortunately, on the downside lately, that's creating needs to rethink service. We're continually adapting service to changing travel patterns and demographics, and oftentimes merging and integrating systems, and those create needs to understand cross-jurisdictional travel demands. And finally, staff is changing constantly, and one of the virtues of having a tool in the databases to support it, it gives you a foundation so that if your service planner retires or relocates, all of a sudden your whole system knowledge doesn't leave the building with the individual, and having a tool and some databases to support it is a way to have some historical information base to use in service planning. Again, high turnover, etc., dynamic situations. We're also in a situation where there was an interest in Florida in having some standardization of methods to ensure some consistency and equity across properties, and we think that's important. Obviously, computing power has improved dramatically and continues to, and so have GIS capabilities with more people familiar with them. And the results, of course, of GIS tools are particularly important for transit, because you can produce the maps and images that are much easier to communicate to both the lay public and decision makers than might be tables and charts, for example. So we really think that the GIS-based platform is a strong benefit to transit planners going forward. In terms of some of the specific characteristics of TBEST, it's really designed to capture walk scale access, and transit's a walk access mode, and so the ability of folks to get to and from it is critical to their willingness to use it. So we need an information set and a tool that really is sensitive to the access to and from transit at a walk scale of geography. And just as an aside there, some previous research we did showed about half the homes in the U.S. are within a half mile of transit. Obviously, half aren't, that means. This also, the tool really captures accessibility via the transit network. In other words, for each transit system stop, this tool knows where you can get to, what share of activities in the community are accessible from that stop, and how accessible are they in terms of time and cost, and fairly powerful measures of accessibility through your transit system. It accommodates special generators for things like park and ride lots, but also special uses that might not be particularly well reflected by the historic reliance on population and employment as means of generating demand. It is sensitive to resident demographic characteristics, and of course we know transit use is highly sensitive to income levels and auto availability and some of those characteristics, and this tool does use that in its modeling work. And we also have information on employment type that's used to support the models in TBEST. One thing that's relatively unique, we know that nationally at least about a third of transit boardings are transfer boardings. Transfer activity is still real important to transit, and understanding that is important in terms of trying to model transit and replicate transit, because those trips aren't generated by the adjacent land use to the stop. They're generated by virtue of the fact that a route is part of a network, and transfer activity occurs at various stops, and we need to capture that to fully understand what's going on in terms of travel demand within transit, and a lot of systems really don't address that particularly well. It is sensitive to fare and speed and frequency, span of service, kind of the classic service supply parameters. It does accommodate fundamental differences in route types, local, circulator, express, etc. And we do know that those routes tend to have different appeal to riders, and so those are treated separately. It's designed to be adaptable to different urban locations without new model equations, i.e. it is a transferable model, and it then is fitted to your geography by matching a calibration year number, but without recalibrating equations in models. It's in effect scaled to fit your urban geography. Here's some basic material on the framework. This isn't a mode choice model. It doesn't use a trip table and decide what share are on transit. It's what we call a direct demand model. So it talks about how many transit trips are generated based on the activity levels and accessibility and demographic characteristics. Historically, folks have looked at route level analysis. We're moving to more precise geography, route segment, and stop level. With that, of course, there's a risk because variability in ridership at the stop level is relatively high, but it gives us a geographic precision that's very helpful for planning. And it does consider all these inter-route relationships, and you'll see here with the various bullet points some of the things that this is sensitive to, routes and directions of stops. It has multiple time periods for analysis, 4 time periods during the day, meaning it's got different equations of forecasting demand for both peak periods, midday and off-peak, as well as Saturday and Sunday, and so it has some sensitivity to fundamental characteristics of transit that are important to its use. It doesn't specifically respond to gas prices or auto travel costs because it isn't a mode choice model, and anytime you build a model, there's some compromises in logic, and one of those is that this isn't necessarily sensitive to gas prices per se, or changes in those. You'd have to do some modifications with elasticities to adopt to any real changes in gas prices. It doesn't respond to kind of the intangible changes in service quality, cleanliness, comfort, reliability, marketing and market awareness, safety, security, presence of shelters, etc. And no other models do either. And we know these things do influence ridership, so we just wanted to make the users understand that there's not explicitly a sensitivity to these characteristics, and of course they tend to be characteristics that aren't quantifiable and able to be used in validation or calibration, but can be important to transit use. It's not interactive with auto travel. It doesn't respond to changes in the competitiveness of transit relative to auto. And generally, that's not an issue. Where it might be is in a major corridor study where you're looking at guideway travel or a longer range plan. And then this may or may not be the best tool for you in that particular environment. In a mid to near-term change, most often improvements in auto travel in a corridor will translate into similar improvements in transit travel in that corridor by virtue of the fact that the lessened congestion benefits the transit travel speed as well. So the differential comparison of the two modes doesn't necessarily change absent an exclusive separate guideway system. The general uses for the tool are strategic planning. 5- and 10-year forecasts for transit development plans in Florida come to mind, but also regular service planning and operations planning that might involve changes in span and frequency, or particular changes in network configuration. If you might be shifting network structures from radial to grid or to pulse time point, etc. This is a tool that you might find useful to explore how that impacts changes in accessibility and changes in transit use. It also has some analysis tools to allow you to look at corridor and areas and sites and understand what's going on in terms of service supply and demographics and potential transit ridership. Fits various size properties, and when we say various size, that means anything from a LA down to a very small community with a route or two, and of course relies on a GIS data management system. We're continuing to work on TBEST through the support of FDOT. We're currently in the process of building capabilities to transition the model from a zonal structure to a land parcel structure of database. And in the state of Florida, that'll mean using a statewide database that's assembled from property appraisal records. So we will have land use by parcel, and then we're using that to generate trip attractiveness, etc. And so that's the next version of TBEST that'll be out later this year that we're pretty excited about. We've also got work programmed in the future. We continue to refine TBEST and support it. Like any software, we do occasionally find bugs, and perhaps more relevant, we have to continue to adapt it to meet changing software packages from Microsoft and SQL Server and GIS, etc. FDOT is recently committed to supporting calibration of BRT and LRT modes, so we will have specific equations for those modes. They can be accommodated now, and their traits can be reflected in the model, but to the extent that there's any differential behavior that has to do with image or other characteristics of those modes, that isn't necessarily captured currently, so we'll be doing some additional research to support that. Some work ongoing in terms of facilitating the ease of which transit networks can be entered into TBEST to let you leverage the existing softwares that might be available as opposed to having to code networks, and continued work to look at things like operating costs, and us, like all modelers, are looking at ways to transition to the fact that we don't have a census long form anymore, and we need to find a way to transition American Community Survey data into TBEST applications. I'll let Rodney pick up here and cover where we're at and move into the demonstration phase.
Okay, thank you, Steve. I just want to introduce first of all, the latest version of TBEST, which is TBEST 4.0, and get into a little bit of some of the technology that's involved, and then talk a little bit about the Parcel model and kind of what that's going to bring to the table, and then also discuss a demonstration of the software itself. So as of about 2 months ago, we released TBEST 4.0, which was a major shift for us into the .NET world, and also to ArcGIS 10. So we upgraded all of our components to the Microsoft .NET framework, so we're compatible now with Windows 7, and as I mentioned, ArcGIS 10. As far as running TBEST, it is required that you have ArcGIS 10 on your machine. So if you make the investment of an ArcView license, which is what is required, it doesn't require the really expensive ArcInfo licenses. So with a minimal investment, you can have ArcGIS 10 on your machine and running with TBEST. It's backward compatible as far as the operating system. It runs on Windows 7, but it also runs on XP and Vista and so forth. Pardon me. One of the major improvements is, what we had problems with in the past was actually getting to admin privileges on the machine. Because we are using Microsoft SQL Server Express, the way we handle that is to have databases that require access to those databases. And we were having some problems with admin privileges and so forth, but this version, we've nullified all that, and the access to the database no longer requires those admin privileges, and it solves a lot of problems for us and headaches for us in terms of bugs and not being able to connect to databases. We also have both support for the free version of SQL Server, which is the Express version, and also the Enterprise version. So if you have either one of those installed on your machine, TBEST will work directly with it. SQL Server 2008 is out, TBEST will work for that, but if you have a database that you're using in 2008 and you want to share your model with someone and they're using 2005, it's not backward compatible, so it won't work on any other machine other than yours. So the recommendation at this point is just to use SQL Server 2005 if you can, or you can use 2008 if you don't intend on sharing your network out. We have put a lot of work into the new UI. It's a good combination of old and new, so it limits the learning curve for existing users and also for new users. There are many new features with this release, and we'll go over some of those in the demo and a lot of fixes as well. So we did have to kind of rewrite the entire software, so that has really worked into this in terms of the UI, the functions, and re-looking at all of our components and fixing what was broken. I do want to get into just a brief look at the Parcel model that we're developing right now. And we're in the calibration mode with it. And so we have a working model. And this is just one of the advantages that I just want to show to you is the kind of stop market evaluation. So for any given stop, we can start to look at what are the land uses that exist directly around that stop in terms of percentages. And the percentages are based on, in this case, the square footage, the building square footage in that buffer zone. So easily you can start to look at land use characteristics for any stop in the system, or even aggregations of stops. What is the land use for, primary land uses for a route or a group of selected stops? And then you can start to look at both the charting side, the report side, and the map side as well. So it really gives you a nice look at any market around any stop. And that's one of the added benefits. Of course, we're using these land use characteristics actually in the model to provide trip rates based on ITE trip generation rates. So it's both a good visual tool in terms of showing what's around a stop, but it's also working into the model so that we're using that information to project ridership. This is another stop. It's more of a multi-use stop where you have a large degree of variation in the land uses surrounding this stop, and it just gives you a good look at some of those land uses, such as shopping centers, single-family homes, churches, stores, supermarkets. So all these things are available to you to look at and visualize. In terms of large market systems, TBEST has been out there in terms of usability and calibration for Los Angeles Metro. Los Angeles has been working on this for many years and has come to the point where they're at the calibration mode. We've got the entire network coded, and we can run the model. We did a lot of updates in terms of capacity, model capacity, to be able to accommodate such a very large system. So that bodes well for the other markets out there that have large systems. So we can accommodate very large systems, such as even New York, Philadelphia, some of those systems where previously they were off limits and really couldn't go there. Now we're able to model those systems. We also have recently generated the TriMet system from Portland, Oregon, and this was generated from the Google Transit feed that was available over the web for the TriMet system. And all we did was, well, we have built a tool that will interface any GTFS with the TBEST model. So you can import your route structure from the GTFS into a TBEST model and into that TBEST network. So that is what we did for Portland and others as well, including Miami and Hart here in Tampa. and others as well. So it's a tool that's been working. We've been working on for a year or more, and it's just now getting to the point where we're really comfortable with others using it and so forth. And it's a tool that we're going to go over a little bit in the demonstration. And at this point, what we're doing is, if you're interested in using this tool, you can provide us with your GTFS. We'll make sure that it works for your GTFS, and then we'll distribute the software to you so that you can use it on your system with your TBEST instance. The TBEST website is operational. It's tbest.org. And what you can find up there are new software releases. You can find training materials, documentation, any reports that have come out recently are available to you there, including a support module where you can actually request support from the TBEST team, and we will provide you with feedback in terms of if you're having a technical issue. We will respond to your request for technical support and assist you in getting your TBEST model up and running. I'm going to present a few features of TBEST, including some of the new tools and features that have been in development for TBEST 4.0. I'm also going to present the scenario summary and comparison tool that was recently developed, where you're able to actually compare scenarios in terms of not only ridership, but all of the variables that are contained within the TBEST model to give a complete view of the differences between any two scenarios. I'm also going to show the GTFS tool, the Google Transit tool, where you can import routes into an existing TBEST network. So with that, I will switch to my desktop view. And I am currently showing the TBEST for the Lynx network. Lynx is in Orlando. But what I want to do is just show you a few things that exist down on my toolbar. One is I have several instances of TBEST currently open. One is for Lynx. I have Los Angeles. I have the HART model and the TriMet model, all up and visible on my machine right now. There are a couple other tools that are available as well, including the scenario reporting tool, which I mentioned, and the GTFS tool. So all those are dockable down here, and you can launch directly from your toolbar into TBEST. I'm going to right-click and just open a new instance of TBEST. And I want to show you when it opens that I have multiple instances of Microsoft SQL Server on my machine. One is the full version, which is MS SQL Server. One is the free version, which is SQL Express. And I can independently connect to either one of these through this interface. Now, if you only have one instance, like most folks do, they'll just have SQL Express mainly on their machine, you won't see this interface. It will go and just directly connect to SQL Express. So this is the default TBEST interface. On the left, you have the TBEST Explorer window, which all of the main windows on the TBEST interface are in panels. So they're auto-hide available, so you can auto-hide any of these panels, toggle them off. If I want to auto-hide the routes, it will go onto the side toolbar, and then I can just bring it back. So all of these panels are available to you to kind of customize your interface, because when you change something, you auto-hide and you pin it, any of these windows, they will stay, and it will save that configuration for you to use the next time you open up. Okay, when we start with the Explorer, we have three main items that are available to you. Number one is a list of transit systems that are currently installed or available on my machine. I have a list of probably 20 or so transit systems that I've been working on and have worked with in the past. There are others that I've worked on, but these are currently active on my machine. If you'll notice, each one of these has not only a name, but also a state in terms of its validation. Some of them, the models have been validated, some are not validated. In the case of HART, it has this 2011 validation, which means that the base year has been set, the model has been validated, and it's ready for future year forecasting. Some of the other models are not there yet and have not been validated at this point. If we drill into some of these, I'll just drill into the links. Let's see, where am I at? Links. Inside of a transit system, as we see it, there are scenarios, reports, search files, corridors, area analysis, and site analysis that TBEST will help you keep track of. So if you think of in terms of scenarios, obviously with any model, you're going to have multiple scenarios that you're testing. And TBEST allows you to easily create, manage, delete any of these scenarios. If I want to right-click, I can create a new scenario right here within the links network. I can also open these scenarios, any one of them. In addition to that, underneath of each one of these, you can look at additional information, including the model status. Has there been a model run on this? And if not, was it edited? It will tell you if it's edited and what models need to be run in terms of the 6 time periods that TBEST models. You also have a set of model logs. So there is a scenario edit log, which will tell you what edits have been happening on your scenario, when they happened, when you ran the model, when you opened or accessed a model, anything that happens, it will log that in this log, and then you can always go back and check and see if your edit took or what you've been doing. You also have logs for the model, and what these direct and transfer boardings logs allow you to do is see the actual kind of model equation in terms of the values that are coming from the variables, the coefficients that are attached to those, and then the output in terms of the estimation and what happened for the estimation of every stop. So really this is a great debug tool. So if you have questions about, okay, I'm not sure what's happening in my model, I'm getting this result, you can always refer to these model logs, go in there, take a look at the stop in question, and see, okay, are my inputs correct? Is the model doing this correctly? What is actually happening, and does it make sense? So it's a great way to debug and see what's happening in the model. All right. All right. Now I showed you transit systems, and we'll come back to those. I want to show you the concept of distribution files. So if you ever worked with a model, you know that you generally will need to either back it up or transfer it to someone else for them to use. And sometimes that can be difficult to do because there's so many files involved, so many input, output, reports, whatever analysis you've been doing, all those things that go into your modeling effort. Generally, to work with all that information, you need to be able to wrap that up into one file and then either back it up, make copies of it, for iterative kind of modeling, or pass it on to someone else. So what we've done is created these distribution files where for any transit system, all you have to do is right-click on it, and I'll just open this up, and if you say create a TBEST distribution file, it will just ask you where you want to save that distribution file, and it will take everything that's available for that particular system, wrap it up into one file, and then you can ship it off. You can upload it to FTPs, whatever you need to do. It happens pretty regularly. So it's a nice tool for packaging and backing up a transit system. The next item that I want to show you is the available socioeconomic data. Now, there is multiple versions of data that's currently available in terms of downloadable information. And this is what I have locally on my machine. However, you can come up to the file menu, and if you go to downloads, you can download socioeconomic support data. So right now we have 3 that are available for download. The most recently updated one was back in May, and it was for the 2000 population and 2010 employment. So this is statewide information that when you click on this, you hit download, it will bring it down to your local, you can extract it, and it will populate it right here in this list, and then you can use that information as your background socioeconomic data for creating a system, for updating a system, the SE data in a system. You can see that one of our more recent one here is for the 2009 population, which we've just been working on recently for the Parcel model, and that involves a lot of data from the ACS that we're still kind of making sure that it's all correct. So one of the things that is available here that generally wouldn't be available right now to the general user community would be this 2009 population, but when we release the Parcel model, that will be released with it. And you can see that there is a Pennsylvania data set. There was a project in Pennsylvania where we actually compiled the entire state for population employment, and so it acts just the same way as the Florida information would, where you can, if you just create a new system, you can select what data that you want to be behind it. So I can say OK, and then I select the counties. So if I want a Gainesville system, I'll select Alachua, and I'll say OK, and I'll give it a name, RTS, and it will actually pull in just the information from the statewide information just for that county. So it doesn't use the entire data set, which is kind of expansive in terms of size. It will just use that for the county. All right. All right, so I'm going to switch in terms of data. I think that's kind of the background of how you can get to data and information in TBEST. What I want to show you a little bit of are some of the reporting characteristics and ways you can, and the information in terms of networks in TBEST. So I've already opened this links network. It is the, I'll show you in the scenarios. You have this CDB growth scenario. It's a recent scenario that created just for growth within the downtown area. You can see the network here. We have all the routes that are essentially within the system. They're also essentially a TBEST route is the pattern. So if you're familiar with the operations of the system, generally you work with patterns, and several patterns will make up a route. So any one of these I can go into and start to look at, and if I want to double click and edit the route, it will show me that route, the extent of it in the map. It will also show me down here on the left, I'll resize this, all the stops that exist along that route. And any one of these I can select, and if you notice it's now also selecting in the map, and I can select multiples if I wish. The same with segments that are attached to this. I can select segments. And stops and segments are all editable in the map window. So if I need to relocate a stop, add a stop, delete a stop, all those things I can do interactively here in the network editing part of TBEST. So in addition to that, we have multiple attributes, especially for the stop level. So what it does is it shows you the route that it's on, the stop ID in terms of the stop ID that is carried by the transit system, the description, and a time point identifier. It will also tell you the number of arrivals and the headway for every stop in the system, and that is maintained, and the in-vehicle travel time between the stops. All those are very important to not only evaluating in terms of service every stop and thus every route, but also in the model, the in-vehicle travel time is used as your impedance calculations for this. You also have special generators, a list of those. So if we click on this, we can get a list of special generators and also amenities. So if you have an amenity that exists at a stop, let's say there's a shelter, there's a scheduled display at the stop, it's also next to the airport. we can code all that information for that one stop, so that later on we can query that. And if it is a special generator, it will also be factored into the model as giving it a little additional boost in terms of ridership. So all those are available to you in terms of that. You can also view, in terms of the data, the socioeconomic data that is associated with all the stops as well. So if you look at this, it shows the total population, total households, the commercial employment, service employment, all the shares of population, income, and household information. All of that is available here and is also editable. So if I wish to, let's say, for a couple of these stops, and I'll just select the first 4, I can change the socioeconomic data for these by hitting this calculator button. And let's say that I want to grow the commercial employment for my selected stops here. Let's say I want to grow it by 50%. With this calculator, all I have to do, select commercial employment. I have this plus or minus of current value, and it will, it's a percentage, so it will grow just for these particular stops. It will grow them by 50%, and it will be complete. So now I've updated that, and all this is available to me in terms of, I have additional information in terms of this local area, and my model will recognize this and calculate that additional employment and factor that into the calculation for projected ridership. All right. There are many other tools that I can probably go into, but we're very limited on time. So what I want to do is, just touch on a couple of things very quickly in terms of what you can do in TBEST. You have reports. You can show a performance report for any time period, including aggregate time period. What I want to show you is, I'm going to group on these validation collections. That's okay. And it's going to give me a report for this system. And the report includes the direct boardings, the transfer boardings, the total boardings. And then we get into some of the performance measures for the system, including boardings per service mile, per service hour, average boardings per stop visit. Some of those indicators that are very important to agencies to have for making decisions about, the viability of any one given route or the entire system. So at the bottom we have a total, so you have all the routes that are listed, and you have a total for all these variables, including, for the entire system. So you can easily get the information on a route basis or the system basis, which is at the total at the bottom. And all that's exportable out to Excel, which is then listed in your reports under your TBEST window. Some of the other types of analysis or reporting you can do stop level, segment level. You can do a regional analysis where you input a zonal shapefile, and TBEST will aggregate whatever variable you would like, total boardings, direct boardings, transfer boardings, or arrivals, into that shapefile and display that on the map for you. In addition to that, you have your network properties such as fare. You can set what time points are transfer stations, and that's included in the model. There's interliners that you can define as well. I'm going through this very quickly, I apologize. You also have service span. So for every pattern, you have a service span in terms of the time period that you're looking at. So if you're an AM peak, for this particular route, you have a 3-hour service span because that's what's modeled. However, you can change that to 2 or 1 hour, and definitely on the weekends. Obviously, that would change dramatically on the weekends, where you have 24 hours potential, but mostly you don't run for 24 hours. Okay. That's generally what you can do. There's some other things in terms of some of the, the ability to search. If I want to do a search for just those stops that have a high poverty level, I have a predefined search for this. I can just double click that, and it will open up and show me that search parameter, and then I can just run that on my system. Okay. I also have corridors that are defined, which are just spatially defined areas. I have area analysis. This CBD, I'll go ahead and open that up. Okay, this is the area that I had defined for this CBD, and what I did was any stop that fell within this boundary, I updated the employment by 50%. So I was expecting in this particular scenario for all the employment to grow by 50%. All right, so just bear that in mind. I want to quickly show you the scenario comparison tool. And I'll just say OK. What this allows you to do, and I'm going to select the links transit system. I'm going to select the weekday time period. I'm going to select the April 2010 scenario as my scenario A, and the CBD growth scenario as my scenario B. So what it's going to do is going to compare scenario A to scenario B for all the routes in the system. And all I have to do is hit show report. And it's going to, I'm going to maximize this so you can see it a little better. What it's going to tell me is, first of all, it's going to give me, the report date, the system, the time period, the scenario A, scenario B. And I have on the left a list of summary variables. Right now I'm just showing boardings variables in my report. And what it provides is that level of additional trips between scenario A and scenario B and the percent change by route. So what you get is a really great look at route by route, what has changed in any given scenario, including those important additional trips that are coming out of this. So you can see the change in direct boarding, the change in transfer boarding, and also the change in total boardings where you have 16% growth per this scenario. I can also change the variables that I'm looking at. If I just want to look at population, I can take off the boardings variables, show population, all my shares, and what has changed. And I can expand this so that if I just want to show, let's say, take it down to total population, I could do that as well, right? There was no change there. For this particular scenario, what we did change was employment. So what I can do is show you the changes in service, commercial, industrial, and then some of the total changes here that happened as a result of our scenario. And then you have the ability to open a chart. So let's just open a chart up. And this is a great way to compare the output of any two scenarios, right? So you can see in the legend you have scenario A, scenario B for direct and transfer and total boardings. On the right you have total. So you can see for the system level, which we say here is the totals, you had a growth from here from 70,000 to 81,000. You can also select individual routes instead of the totals to show. So you can start to look at, okay, what was happening there directly. And maybe I just want to show total boardings instead of all boardings. I can also sort this. So if I sort by total boardings, now I have a nice look at, okay, route number 8 was my best route. And then it kind of goes down from there. So it's a great way to take a look at that, and you can just save this out as an image and put it directly into whatever report that you're generating so that it meshes with a lot of the information that TBEST keeps as well. All right. And then one last thing that I want to show you. There's several other items with that, and I encourage you to look at some of the documentation on what you can do with this scenario comparison tool. Because you can summarize not only two scenarios directly, but you can just summarize one scenario if you want to, or you can summarize in a particular geographic area. So for what we were doing, we had this mobility area is what we're calling them here. I had this CBD, which we defined here over in the map. What it will do is tell you the differences in ridership that exist or all the other variables just within the CBD, right? So if I hit show report here, I'm going to get a report that shows me the differences that happen just within that zone.
Okay, Rodney, it's Phil. I think this is great. I want to give the opportunity for a few people to ask some questions. I know we told everybody we'd try to wrap it up by 1, so are you we all set for questions?
Sure.
Okay. Let me give people an opportunity to ask the questions. Primarily, if you click on Q&A in the upper left-hand corner of your screen and type in your question, we'll just start filling them from that. If we're not able to complete, if you want to hang in, we can go a few minutes long. If you want to ask your question, we can also share those with Steve and Rodney, who I'm sure would be happy to respond to you afterwards too.
Sure, and Phil, if you can put up that contact slide, the last one in the presentation there, that'll give folks both email addresses. I believe it's there you go. Feel free to contact either myself or Rodney, or contact us through the TBEST website as well if you'd like. As I think you can see from what was covered today, there's just really a tremendous wealth of things you can do with the tool that go well beyond the traditional demand forecasting to allow you to look at land use and development scenarios and different growth scenarios, as well as address some of the policy issues like equity or jurisdictional service supply and demand, et cetera. And so it continues to find more uses because it is really, it houses some powerful demographic and service databases, and that lets us really, do an awful lot of work with the tool to help folks address questions that come up in their areas.
Steve, you mentioned, I think one question some people have right now is, you mentioned that there's going to be I think a BRT component. Could you elaborate a little bit on that?
Yeah, we're as folks are probably aware, bus rapid transit is can currently be entered in and part of the transit network, and it has its own characteristics of speed and cost, etc. But the data suggests that both guideway modes and BRT have a different appeal above and beyond that can be explained by speed and cost and frequency of service, that has to do with the image and the physical presence of those systems. And because of that, we want to develop specific equations that will give us what we hope are accurate estimates of BRT and LRT ridership within this tool. So that's one of the future research projects that we'll be addressing over the next year. So certainly bus rapid transit is something that's being actively considered in virtually all urban areas these days, and we want to make sure that the tool works as best possible for that application.
Does TBEST have a users group?
It has a group within the website where you can post questions and get Q&A answers and follow it. That way is currently the forum that we're using to communicate with the users. Also, one other reminder, if there's folks that couldn't attend today or other folks in your agency that might want to watch this, it will be recorded and available, so you may want to steer it to folks that might be part of the decision as to whether or not you think about using TBEST in your application or your agency.
Yeah, thank you, Steve. I failed to mention that it is recorded and will be available probably by tomorrow.
Yeah, and we'll link that to the TBEST website as well as the CUTR website. So folks want to access it.
Another question we have is to input a transit network into TBEST, including the bus stops and additional data. Does a GIS network shapefile do the job, or do we have to enter each route manually or as a database?
Rodney, I'll let you handle that one and talk about the various ways they can enter data.
Okay. All right. Well, there's a few ways at this point that you can enter data. One is, yes, you could digitize it directly from within TBEST, all your routes, including the segments and stops. The other way is that about 4 or 5 years ago, the CUTR had a project where we coded most of the systems in Florida. So if you are in Florida, you can at least start with a network, although it's a little aged at this point. You have something to start with, and that's available just for download within the TBEST software. So it's under File Downloads. You can go directly to that and download it. The other option is the GTFS option. So if you have your system in a Google Transit feed, we can take that feed and really kind of create a network from it. So at this point, and it's not really for all feeds. There are certain requirements that need to be met in terms of what data is in the feed. So in particular, the shape stop text has to be in that feed. But generally, most folks have that, and we've already generated the Miami model, like I said, PSTA, HART, and some of the others, including TriMet out in Portland. So that is also an option. But
and folks can enter routes manually. It's not all that laborious. It's a quick and a point-and-click type of method for entering routes, and obviously you have to put in the service data as well. But it's certainly very doable, particularly for a modest-sized system.
That's correct. And there's a lot of help in the user manual for doing that. So if you want to attempt that and do that, there's a lot of information in the user manual that tells you how to do it.
All right. Well, in the interest of respecting everybody's time, I'd like to thank you both for your presentation today. Remind everybody to, if you would, take a minute, fill out the evaluation. If you are AICP through the American Planning Association, we've applied to see if this will be qualified for certification maintenance credits. You just indicate that, yes, you're interested, and provide your contact information at the bottom. And we have a growing list of courses that have been accepted by APA for those that are in the planners. So again, with that, I'd like to thank everybody for attending today's CUTR Webcast. Have an enjoyable holiday, and see you in a couple weeks. Bye.
Thanks much.
Thank you.